Today we're doing lesson 9.6, area of composite figures. So for our warm-up today, we have this weird shaped figure. We kind of saw something like this on your homework last night. On your homework, you saw a figure that looked like this. I believe, somewhat, more or less. So how do we go about solving figures like this, Hannah?
You do 1/2 times height times base 1 plus base.
That's excellent. That is how you find the area of a trapezoid. But is this shape exclusively a trapezoid? No. So this shape is not exclusively a trapezoid. So does that mean that we have to learn a new formula for area? No, why not? Lily, what do I have to do?
You have to separate the first shape, that part.
Yes, I'm going to separate the shape into parts. So I'm going to cut it right there. And when I cut it right there, it separates it into a trapezoid, as Hannah was saying, and a rectangle. So I broke it apart into these two pieces right here. Our trapezoid has a length. We'll go and look at that in a second. What actually is the length of this red line right there? What is the length of that, Ben? 4. And Elsie, how did he get 4?
You subtract 5 by 1 since they're both lengths.
Exactly. So we see here, which is not the line that I'm doing, but this is the end of my trapezoid. It's made up of a piece that is 1 length, and the entire thing is 5. So then, obviously, the remaining part must be 4, because 1 plus 4 is 5. So we see that here. Our trapezoid looks like that. It has 1 base of 3, 1 base of 4, and a height of 2. Then we've got our nice little rectangle. Super easy for us. It's got a side of 2 and another side of 5. So based on that, Hannah gave us the area formula for trapezoids. We heard that. It's 1/2 height times base 1 plus base 2. Who has the area? I'm actually going to pull a stick. Who has it? Malia. Of the trapezoid? I'm going to call on you for the area of the rectangle then. 10. Exactly. The area of a rectangle. The formula is area equals base times height. Any 4-sided figure that has parallel sides, that is the formula. That's it. If you see that, it's still the same formula. If we see a nice little diamond, still the same formula. So now we've got this trapezoid. Let's see, Fernando, what did you get for the trapezoid?
7.
He got 7. Let's see. We have 1/2 times 2 times 3 plus 4, because I chose base 1, base 2. Does it matter which base? No, either base can go, because if I did 4 plus 3, that's the same as 3 plus 4. So let's cancel some stuff out. What are the things that I can do here? What can I do? Can I cancel anything out, Lily?
Do 2 divided by 3.
Yeah, that 1/2 times 2. That's 2 divided by 2. Boom! That's gone completely. It just becomes a 1. And does a 1 matter? No, doesn't matter. 1 times, and 3 plus 4 is 7. So 1 times 7 is 7. So what would the area of this shape be then? What would the area of this shape be, Adriana?
7 squared.
Not 7 squared. It's a great idea. Anita? 17 on its own, not squared. Because all we did was we combined the area of this rectangle, which was 10, and we combined the area of the trapezoid, which was 7, and we added them together because those two shapes are together, and we get the answer to be 17. So we saw something like that on your homework. I want you to write this down in your notebook. A composite figure is a figure made of 2 or more two-dimensional figures. The composite figure shown to the right is made of 2 rectangles. So we see this. We've dealt with composite figures before, actually, and when you're going to draw this, we're going to look together, because we'll just draw this together. We'll see an example of a composite figure that we've all come to know and love. Ben, I want you to come up here, and I want you to draw a composite figure made of a rectangle and a right triangle. Thank you, Ben. Let's see.
So you can call it long.
So let's see what Ben draws. Don't tap too hard. Just
Okay.
Excellent. That's great. He drew a composite figure made of a rectangle and a right triangle on the paper below. When we draw our composite figures, we tend to not have this little line in the middle until we put it there. There's no problem with the fact that he did right now, but our figure would look like this. What shape is that, you guys? Rocco? It's a trapezoid. We saw that in our first lesson on trapezoids where I showed you the proof. Just as Ben did, we break it apart. We break it into pieces. So now we have a triangle and a rectangle. What would the area of Ben's shape be? If you're having trouble seeing, I'll mark the sides. This is 3. This is 2. The bottom is 5. So, once again, it is a trapezoid. There are 2 ways to do this. We could use our trapezoid formula, or we could use our proof formula where we break it into 2 composite pieces. Ben, let's solve your problem. What'd you get as the area for your total composite figure? So Ben got the area of 10. I'm going to write that darker so we can see it. Ben got an area of 10. So first we're going to look at it with our formula. Our formula, as Hannah said earlier, is 1/2 times our height times base 1 plus base 2. Let's rewrite that. We have 1/2 times our height. What is our height then, Romario? Not 6. What is it, Rocco? 3. So our height right here is 3. What's our base 1 then? What is our base 1, Andrew? Perfect, 2. As such, Rafi, what's base 2? That's a good guess. Right now we're doing the trapezoid formula, so we don't have that. You're really good if we were doing the triangle. Anita? 5. Exactly. Right now we're doing the formula for the trapezoid, so we're treating it as one shape. So now we've got 1/2 times 3 times, and 2 plus 5 is 7. So when we do this, we get 3 times 7 is 21. 21 divided into 2 parts times 1/2, we get 10.5. Excellent. Here's the proof version. Here I have my rectangle, and here I have my right triangle. We already know my rectangle, 3 to 2. So what's the area of my rectangle then, Michelle? 6. Excellent. So the height here, we still have 3. But what is this length right there? What is that base? Matthew. Perfect. So we get 3. Now we've got 6 for our original, for the rectangle. What's our area formula for a triangle? What's the area formula for a triangle, Ben?
Half base times height.
Perfect. 1/2 base times height. Our base is 3. Our height is 3. That makes it 1/2 of 3 times 3, which is 9. 1/2 of 9 is equal to 4.5. And if I add 4.5 and 6, again, I get 10.5. So when we're doing this, like I said, there's 2 ways to do it. And you have to know both ways because sometimes you have to break it apart into this proof. So, for example, we're just looking at this. What 2-dimensional figures are used to make the shape of this pool? What 2-dimensional figures? Which ones, Romario? And what else? Trapezoid and a rectangle. Excellent, Romario. We've got our trapezoid shape right there. And we've got our rectangle right there. So here, we got a trapezoid and we got a rectangle. So how could you determine the area of the pool floor? We find the area of each and then we add. So I want you on page 717, find the area. On page 717, find that area. Alinza, what did you get for the area of the rectangle? You're writing it down? Well, what are you multiplying at least? Perfect. So we're multiplying base times height. Excellent. So I'll come back to that. Alinza, the answer you got was 392. Excellent. Perfect. Jasmine, what is 1/2 times 2? 2 halves, which makes? If I have 2 halves of something, how much do I have? We get 2 halves is equal to 1. So that goes away and it's just 1. And Jasmine, what is 4 plus 6? 10. So we have 1 times 10, which is 10. Excellent. So who can tell me the full area of this shape? What is the full area, Gloria? 492?
402.
Oh, 402. Okay, that's why I was like, so our area is 402. We just added the two of them together because they are both part of the same pool. Excellent. So I just want you to look without flipping our book. It says find the area of the figure at the right. The figure can be separated into a rectangle and a triangle. We see this. We already know the height of the triangle. Who can tell me the base of that triangle? I want to know the base of that triangle, Melanie. Perfect. It's 4. How'd you know it was 4? Hannah, how'd you get 4?
6 minus 10 inches.
Perfect. 10 minus 6 inches is 4. This whole length is 10. This length is 6. So to make it equal to 10, the whole thing, it's 4. So now I've got a triangle there, and I have a rectangle. What's the area of that triangle? Our formula is 1/2 base times height. Our base is 4. Our height is 4. What's 4 times 4? Gore. 16. What's half of that, Nathan? 8. So the area of the triangle is going to be equal to 8. And then the other one, I've got a height of 6 and a base of 10. And it's a rectangle, so it's just base times height. So what is it, Emerson? Perfect. So for our rectangle, we get our height to be 60. So what would our total or area to be 60? So what is our total area then, Anita? 68. Excellent. And let's follow down. Area of the rectangle, area of the triangle. We have 6 and 10. Area of the triangle, 4 and 4, exactly what we broke down. Here, area is length times width. So we get 10 times 6 or 60. Area of triangle is half of base times height. So we get half of 4 times 4, or we get 8. When we add them together, we get 68. Excellent. I want you guys to find the area of this shape. It's already broken part of it down for you, but you have to break it up one more time. You have to break it up one more time. Daniel, how did you break apart this shape? So you drew a horizontal line like that, right? Excellent. Now we have a trapezoid here. We have a trapezoid here. And we have a rectangle here. Did anybody divide it differently? Lily, how'd you divide it?
I divided it from...
Like that?
Yeah.
Excellent. Whose way is correct?
Both.
Both ways are correct.
It's just a different size.
Exactly. So, Daniel, we did your or what'd you get for your formula here then? First of all, what is your base, Daniel? What is the bottom base?
36.
Your bottom base is not 36. What is it? What is it, Anita? Your bottom base is not 20. What is your bottom base, Gloria?
It would be 26.
It is 26 because the whole length is 36. This length is 10. So what's left over is 26. So for the height of the rectangle, I'm going to call Rafi. Daniel, what did you get as the area for your trapezoid? So he got 138. Now, we needed to find the height. Daniel, how did you find the height of that trapezoid? Excellent. The total height minus 14 because this part here is 14. As we can see, it's 14. So this whole thing is 20, which leaves us with this height being 6. Our formula, 1/2, 6 times And we have 20 plus 26. 20 plus 26. We get 1/2 of 6 is 3. 20 plus 26 is 46. When we multiply, we get 138. Rafi, what'd you get for the area of this rectangle? So the area of the rectangle, we find here is our height, here is our base. So we're going to be multiplying 14 times 26. Who has 14 times 26 for me? Elsie, what'd you get?
364.
Perfect. So we get our area of this one to be 364. And Anita, how do we do this one? This one's already nicely set up for us. What's the area of this trapezoid? So she got 140 because it's 1/2. Our first base, I'm going to write it up right. It's 1/2. Our height is 10. And then our bases are 14 and 20. So we get 1/2 times 10 is 5. 14 plus 20 is 34. And 5 times 34 is 170. So based on this, who can tell me the area of the full figure? Elsie.
672 square feet.
Perfect, 672 feet squared, or square feet. Excellent. We did that by adding together 138, 364, and 170. Lily did it a different way. Lily split it into 2 trapezoids like this. So if we're looking, we're going to go through this fast. This base. So we've got this part here, 10, and this base right here. This part is 20. This part is 20 because we see it's 20 up here. So we're doing a rectangle of 20 times 20. Gore, what's 20 times 20? 400. And then here, we have a base of 20, a base of 14. And if we have 20 and 10, what we're left with is 6. So we have 1/2. 6 times 14 plus 20 is 34. This becomes 3 times 34. We did that already. 3 times 34. Actually, we didn't do that yet, but it's 102. And then lastly, we have a height of 10, a base of 20, and a base of 14. So we'd have 1/2 times 5, or times 10 times 34. 1/2 times 10 is 5. This is the one we did. 5 times 34 is equal to 170. We add them all together now, and we get 400 plus 170 is 570. We add another 100, we get 670. We have that too, 672, just like we got there. It is the same exact area. So you're able to split it. If you really wanted to make your life difficult on you, you could split it into a ton of shapes, actually. You could split this into... We could split this into a triangle here like this. So then you would find the area of that triangle, the area of that rectangle, the area of that triangle, the area of this rectangle, and the area of that rectangle. But do we really want to do that?
That's too much.
No, it's too much. We want to split it into as minimal shapes as possible. So here's a little interesting one. We have to find the area now of overlapping shapes. So we got to find the area of overlapping shapes. When we do this, we have to find the area of each of our square/rectangle, but part of it overlaps. Hannah, what is the area of this square? I want to draw it like this. What's the area of that square right there? Perfect. It's 144. Great job. So the area here is 144, including that box. Then let's see. Lucy, what's the area of that one right there, the other one? Excellent. So here we get 180, right? So that means that my total area is going to be adding them together, and I get 324, right? No, why not then, Ben?
Doesn't the second one have the orange one have to get
It's not that it has to be above the figure. It's that
Composite figure.
it is a composite figure, sort of. It's that this part overlaps, which means that right now we're counting it twice. We have to remove one of those pieces because we counted it in that square and we counted it in this rectangle. It's counted twice, but it only exists once. So we have to remove that piece. What is the sides of this rectangle? So we know that this length is 15 and this part's 8. So what is this top part right there? What base is that? What's the base then? Daniel? 7. Excellent. And we know here, this height is 12 and this height is 6. So Jenna, what is the height of that part? Of this part right here, the part that, what is the height of that? Perfect, it's 6. Because the whole is 12, we're taking away 6, we get 6. The area in the middle then is 7 times 6, which is 42. That one, like I said, was counted twice. Hannah counted it in her square. Lucy counted it in her rectangle. Can we count? Do we have it there twice? No, it only exists there once, this overlapping shape. So we have to get rid of it. Our total beforehand was 324. But now what am I going to get as my answer then, Adriana?
I don't know. I was gonna ask.
Hannah, what'd you get?
I got 282.
She got 282. Ben, can you confirm?
Oh, yeah, that'd be right.
Yes, exactly. Because we subtracted 324. We take away that 42. So our total that we got is 282. If we look at this, the square is what Hannah said, 144. The rectangle is what Lucy said, 180. So we add those together, we get 324. But the overlapping area is 42. So we have to subtract that overlapping area, and we get the answer that is confirmed, 282. I want you to go to page 718/719, and you're going to do problems A, B, and D. So we're going to break this shape into two parts. I broke it into a trapezoid and a rectangle. This other one I broke into a trapezoid and a rectangle. 10 times 7, because we're doing our rectangle, we get 70. This base is 7. What is this height then? Who can tell me that height? What is height, Elsie? 3, exactly, because if the whole length is 10 and this part is 7, we're left with 3. So we've got 1/2 times 3 times, and 5 plus 7 is 12. Let's see, I'm going to just cancel because I'm lazy. We cancel out that half and that 12. We get 6 times 3, so is equal to 18. So then what's the answer? What do we get for the answer to our figure here? This is not. Gloria's right. It would be 7 times 7. That's why we're doing that, because I broke it apart. I forgot to do that. So Gloria's right. It's 7 times 7. In which case we get 49, not 70. Silly Devin. Misty is. So we add them together. We get 49 plus 18. And what did you get, Gloria?
67.
67. Excellent. That's the shape. Here, we have a base of 4. We have a base of 10. So we've got 1/2. Our height. What is our height here? What's the height that we have here? Lily. 4. Because 4 plus 8 equals that whole length of 12. This part is 8. This length is 4. The whole length is 12. So I have 1/2 times 4 times 14, because I added that 10 and that 4. Excellent. I'm going to cancel out this. It becomes 2. 2 times 14 is 28. So I get the area here to be 28. And then I've got my nice little rectangle on the other side. And I get 4 times 8, which is 32. When I add them together, I get 60. Let's look at this overlapping shape. I'm not solving these, but we also could have broken it apart like that and like that. Oh wait, I did break it apart like this. We could have broken it apart like this. So there's multiple ways that we can do it, as long as you break it apart into two composite figures and do the right formulas. Here, let's find the area of that right there. What is the area of this one then? Who can tell me? Lucy. 42. Excellent. Let's find the area then of this part? What's the area of that part? Ben? 48. And then Anita, I want you to tell me, what's the area of this part right here? First, let's find the sides. What is the length of this side? If the whole side is 7 and this part is 2, what is the length of the other part? Anita? 5. Excellent. And then lastly, if this whole part is 6 and this is 1, what is the length of that other base? Ben? 5 as well. So that means that this middle area is going to be equal to 25. We have to take away that area. So now we have a total of 42 plus 48. 42 plus 48, we get 90. Then we have to take away that composite area of 25. We subtract that, and we get 65 as the area of our shape. Here, we've got the area of Matthew's apartment. Here, we've got the area of Charlie's apartment. But in the middle, we've got to take out that patio. The area of Matthew's, the area of each apartment, they're the same. 55 times 45 is 2,475. The sum of the areas, we add those areas together, is 4,950. But we have to get rid of that patio area. The patio area is, the whole length is 55. This length is 55 minus that bottom 32. So we get that length to be 23. As such, this length is 44. But this other length is 22, and it's the exact same for both of them. So we get that 23 here because we have to get to 55. The area there is 529. We subtract, so the total area is this. For our guided practice, we do numbers 1 and 2, and your homework is page 721, numbers 1 through 6. For those of you having trouble, we see this. We're going to be taking the area of this square. That's 28 times 30. 28 times 30 is equal to 840. Then we have the area of this other one, which is 42 times 33. That's going to be equal to 1,386. But we've got this limbo area, the locker room, and we have to find the length of those sides. When we find the length of those sides, we know that the whole length here is 30. This length here is 16. So what is the remaining area? When we do that, we find that it is 14. Similarly, here, we know this is 28 and that part's 14. 28 minus 14, we get another 14. So 14 times 14, we get that 196 that we're going to have to take away. So 1,386 minus 196 plus 84 gets us 1,274. Although I have a feeling I did something wrong because it's definitely 840 and I was messing up. So instead of that, we have 840. And I get my answer to be 2,030 feet. Excellent. When we actually add correctly. Thank you, Miss Diaz. Here, we break it apart into different parts. I have a shape here. This is my trapezoid. Here I have another trapezoid. If I know this part is 8 feet and the whole is 25, what's left is 17. And I already know my height here is 10. So our rectangle's height is 170. Here, I know my base is that same 17. And the height is that 5. So then I've got 1/2 of 5. One of my bases is 17. The other base is 12. We see that there. 17 plus 12, we get 29. Times 5, we get 77. And when we divide it by 2, we get 38.5. So far, the composite areas that we've got are 170, 38.5, and we have to find the area of the trapezoid again. If this whole area, let's look at this one right here. When we look at this length, we know it's going to be 10. It's going to be our 10 plus our 5. That makes it equal. So this is 15 as our bottom base. We get 1/2. This length is 8. Then we've got 15 plus 10. 1/2 of 8 becomes 4. 15 plus 10 is 25. So we find the area of that last trapezoid to be 100. We want to add them all together. So we get 100 plus 170 is 270. 270 plus 38.5, we get 308.5, which matches our answer. Not there, so I did another mess up. But it doesn't matter. Go back and check. We just need to find the bases. Excellent work. Once again, our homework is page 721, numbers 1 through 6. So now that I fixed my mistake, I found out that this bottom part is 17, this is 12, this height is 5. 1/2 of 5 times, and we add that 17 and 12. When we do that, we get 29. 5 times 29, we get 145. We divide that by 2, we get 72.5. This time, when we add all of these together, we do get that 342.5. So be careful, because if I keep making mistakes on this, you will keep making mistakes on this, so make sure you show your work. Excellent.